Hello, and welcome to the ACE Core lecture-based course. So just a quick introduction. My name's Kyla. I'm going to be doing most of the course, probably all of it, using pre-recorded lectures. So this is the first time we've done something like this. So we're just going to see how it goes. Just a reminder though, if you do have any questions or if you're a student working in the classroom and you're using this as a resource, don't hesitate to ask your math teachers, or if you're working online, you can send an email to myself or your online teachers, as well as the booklets that are provided in this course in the content area. So we have a few textbooks that you can work from and read through, and there's practice exercises. This is just meant to be an extra tool for you to use, a little bit different than the textbooks, and to see a teacher actually teach it, sort of. So I'll be using a whiteboard, so to speak, and sort of writing on the slides. And we're going to see how it goes. Now, I'm not sure how it's going to go with sharing my scientific calculator, so we're going to try that out today because I would like to teach you how to use your scientific calculator. This scientific calculator was downloaded using a link that I can provide to you, and probably I'll add it to the resources section of the webpage. So we're going to try to get started. So today we're going to learn how to use a scientific calculator, some basic algebraic definitions. So what is a variable, algebraic expression, equations, what are like and unlike terms, and how do we collect like terms? So we're going to get into adding and subtracting. If this is a little too advanced for you or you need extra clarification, you can always ask your instructor. We do have additional resources, but this is meant to sort of introduce you to these terms. So don't try not to be super intimidated as we get started, because it can be a little overwhelming at first if you haven't seen algebra in a while. So the first thing we're going to learn is we're going to learn some buttons on the scientific calculator that will be your best friend. Just give me a minute here to share my screen with you. So hopefully you can see the scientific calculator. It looks like you can. And on the scientific calculator, we have a few really important buttons that we're going to use. So just some of the basic ones on the side here is your addition key, your multiplication, division, and this is subtraction. One of the biggest confusions on this is the negative sign. So subtraction, we're going to use this button, but if we're trying to plug in a negative number, and I'll explain that in a little bit, we're going to use this key. So this is the negative key. So let's, for example, I have 5 plus, and let's say I had a -2. So this, you can notice, gives that negative sign in front, and then we're going to hit equals. And that will do, that will take the plus and the minus sign, and it'll actually do the operation for you. We'll talk a bit about what happens when you have a plus and a minus. But it's important to know, but also the calculator does a lot of these operations for you. So we're using this calculator as a tool in this course, and again, I will either email you the link or post a link in the content page. If you don't have a scientific calculator, we do recommend the Sharp one, just because it is very user-friendly. It has all the buttons we need, but any scientific calculator will work. Most of them will have this plus minus key looking like this, but some of the other keys might look a little bit different. So if you are a little bit confused, you can always Google and try to figure out where that key is, or you, again, can ask your teacher and we can help you out. We've seen pretty much every scientific calculator out there. So that's the negative key. We also have our exponent key. So you can see it's a little y to the x. So this is your exponent key. And on this, you're able to, let's say, do 5 to the exponent. So see how it does that little up arrow? That's your exponent key to the power of 2. So what is 5 to the power of 2? Hit the equal sign, gives us 25. There's also the square key. So you can see it's an x squared. That's if, so we could have also used this to figure out that one. So we could have done 5, hit that button, and that would have given us 5 squared as well. But the problem is we don't always have a power of 2, or in this one, we also have a power of 3. So these are sort of shortcuts, but sometimes if we have a power higher than that, we need key to be able to do that. So let's say I had 5 to the power, or exponent, of 5. That gives me 3,125. So this button is your exponent key. This button is your square root key. So this is specifically a square root. So let's say I wanted the square root of 81. Hit the square root button first on this calculator. Some calculators are different. This calculator, we hit the square root first, then type in 81 equals, and that gives me an answer of 9. But again, and I hope you can see it here, it's probably very small on your screen, but there's an X sort of square root key. So this one is the exponent key, and this one's sort of the opposite of it. So if I have a fourth root, so maybe not a square root, we hit 4. Second function allows you to get to any of these yellow or orange buttons. Like above it, it'll have the button that it can be if you hit second function, if that makes sense. So the second function allows me to access anything that's in orange. So I hit 4, second function, this button, and then let's say 25. That's going to give me an answer of 2.236. We'll talk a bit about rounding throughout this course, but that is the button for the X root. And then another button, and probably the best one on here, arguably, is the fraction button. So this is your A, B, C. On some calculators, it'll look a little bit different, but usually it's in sort of this format. The A being the whole number, and then the B over C being your fraction. So you're able to put in a mixed fraction and a proper fraction. So let's say I had 5 halves. So we're going to hit 5, ABC 2. So that allows me to put in the fraction plus, let's do 3 over 6. So I hit 3, ABC 6. And that gives me an answer of 3. So what it does is the calculator does all the work for you. So you're not going to have to find your common denominator or anything like that. So this is really helpful throughout this course. We don't expect you to have to be able to do this without a scientific calculator. But if that's something you're interested in, again, you can ask your teachers. We have extra resources, or we can sit down with you and teach you how to do this using a pencil and paper, so to speak. But really what we're trying to do is get you to use the calculator so that we can get into more advanced math in a sense that's not focusing on numeracy. So these algebra questions will have a lot of fractions in them, but we're really trying to get you to learn, some more complicated questions. And so in that case, we often use a scientific calculator to sort of save time on the long work, like the work of being able to do these fractions in your head or on paper. So the slide that I had was, I'm going to stop sharing this for a minute here, was supposed to have some questions that we could do together, but I'm going to try and share the whiteboard, and maybe we can just come up with some questions together, but this might be a little tricky. So I'm going to try to bounce between the whiteboard and the calculator. So we talked a bit about the negative sign. So let's say I have 3 plus a negative 4, and I want to figure out what that is. So again, we can use our calculator. I'm going to write out the keys that you're going to push. So you're going to do a 3, the plus sign. So I'm going to put in squares the buttons you're going to push on the calculator. And then we're going to have to hit the plus minus sign. Again, on your calculator, you might have to hit this after you enter the number. But on this calculator, we hit the plus minus first, 4, and then we hit equals. So let's see what this looks like. So we're going to hit 3 plus, we're going to hit the plus minus sign and a 4. The calculator will put this in brackets for you. You could have also added those brackets around. So the bracket key right here is this bracket, this bracket. It would have given you the same answer. So it'll actually double bracket it for you. But a lot of times we try to say use more brackets than less, because often our calculators will do the operations without, sort of in a different way. The brackets allow the calculator to know when an operation needs to be done first. So let's say I wanted to use the brackets. I would go 3 plus bracket negative 4, oops, right bracket. So see, it will double bracket it, but that's not a bad thing. That's not going to change our answer. It's still going to spit out a negative 1. So let's go back to the whiteboard here. If you're really familiar with using a scientific calculator, you can skip over this part. You're able to fast forward and rewind on these videos. So if this is sort of something that you don't need to watch, you can always skip forward to when we start the algebra part of the of the class. So, okay, so let's look at, what should we do next? Let's do the root sign. So let's say I had the sixth root of 3046. So that's a 6 if you can't see it. So we're going to hit the 6 first, then you're going to have to hit second function, and then you're going to hit that YX button to access the X root. So I'll show you again on the calculator, and then we're going to hit 3046 equals. So let's go, so 6, I'm going to write this down so that I don't forget it. Okay, let's go back to the calculator. So to do this one, we're going to hit the 6, second function, root, and then 3046 equals, and that'll give me the answer of 3.807, so 3.81 if you wanted to round to 2 decimal places. So again, the second function gets you anything in orange. Okay, let's go back to the whiteboard. Okay, so let's look at a fraction question. So maybe I have I'll switch back to blue, but that's okay. 3.5 times 2.5 plus 3 4/6. So the brackets are important to enter here because the brackets, remember, if you go back to BEDMAS, we have to do brackets first. So that means that anything happening inside these brackets needs to be done first. The calculator will know, though, once you enter these brackets to do that operation. So the calculator has it sort of programmed in it to be able to do this. To enter a fraction, again, this is our fraction key here, the ABC. So we hit the 3 first, then ABC, 1. We hit it again for a mixed fraction. So when you have that whole number and then the fraction after, we just have to hit this button twice. So the 3 and 1/2, like that. And then we're going to hit that left bracket, 2 and 1/2 plus 3 and 4/6 bracket equals, and it's going to give me 21 and 7/12. So this is a good opportunity to show you how we can make this. So this is called a mixed fraction, but we can make this into an improper fraction as well as a decimal if we want. So how do we do that? So if I hit, so this is my fraction key. I think if I hit second function and this button, it'll make it into, see how it says D over C here? That means it'll make it into a fraction that has 1 over top of the other. In this case, we call it an improper fraction because the top number is bigger than, so the numerator is bigger than the denominator. So it will switch that to us. So sometimes that is helpful depending on the question. And then if I hit it again, just the button, it will switch it to a decimal. So if I hit this, each time it'll go from my mixed fraction to my decimal, like over and over. I can hit it as many times as I want, and it'll go back and forth. So this expresses the decimal as 21.58. If I hit second function again, it'll bring me back to that mixed fraction. So this button is really helpful if you need to go from, sorry, this is an improper, to go from, whatever, depending on the question or what's being asked. Sometimes in graphing, we want to have it as a decimal because it's easy for us to graph. There's many uses to being able to use that button. So that's how you would do that. Okay, let's say I have 6 to the power of 4. How am I going to do that? So on my calculator, I'm going to hit my 6 first, then my exponent key. Some people's exponent key will just look like an upper hat, like the up arrow that the calculator ends up looking like. But in our case, ours looks like this. And then we hit the 4 and then the equal sign. So let's go back. Okay, 6 to the exponent of 4. So again, 6, the YX button, 4 equals 1,296. So there you go. It's done it for us. Another key we can talk about is the pi button. So you might end up having to use this, I don't think so much in this course, but probably along your academic career, you'll have to look at the pi button. That's an important one. This EXP button is used when we're talking about scientific notation, but I don't know that we'll get into that in this course or very much, but you'll probably use this button a lot in your chemistry course if you're taking chemistry. And yeah, I think we're going to stop there. If we end up needing to talk about more buttons as we go, I'll just pull up the calculator and we can talk about it as we go. But we'll get into the algebra now. Okay, so we'll go through some definitions here. I'm hoping that I'm able to write on the PowerPoint for the most part and don't have to go back and forth between the whiteboard, but we'll see. Hopefully I can figure that out. Anyways, so some definitions. We'll start with some definitions. Just give me a second here. So first thing, what is a variable? So a variable is a letter or symbol that represents a number. So a variable, just again, it's just a letter, and you can use any letter. So we talk about that in the next slide, but usually we use X or Y. In most cases, we use X or Y as a variable, but in a lot of different formulas in physics or chemistry, there's other letters that we will use. So you can use any letter. It's just a symbol or a letter, in this case, that represents a number. So this N is actually taking the place of a number in this case. Okay, so let's move to the next one. A variable can use any letter, so that's what I just mentioned, of the alphabet. It can also use symbols, so you might see like delta, sigma, some Greek letters. But in this course, for the most part, we're just going to use letters of the alphabet. So an example is n plus 5, so you have the variable n there, an x, a w. So just some, some introduction to variables. So an algebraic expression is when you have a group of numbers, symbols, and variables that express operations or a series of operations. So it's just basically, it has a mixture of letters, numbers, symbols that express some sort of operation. But for the most part, what we're going to see, well, actually, we're going to talk quickly about evaluating. So again, because these letters are taking place of number, we can sub numbers into this. So sometimes we'll see in this, I think in the second part of algebra, we'll start doing some substitution. But if I have m plus 8 and I'm letting m equal 2, then the m can get subbed into this expression of m plus 8, and we can say 2 plus 8, so we're putting the 2 in for m, is equal to 10. And then in the second expression, r minus 3, if we let r equal 5, we put 5 in where the r is, and we get 5 minus 3, which equals 2. So we can evaluate algebraic expressions by substituting in numbers or variables. So an equation. So this is what we're more so going to look at in this course. And we're going to learn how to solve equations. We're going to learn how to collect like terms and so on. So a mathematical sentence, we like to say, stating that two expressions are equal. So you've probably heard, or maybe if you've taken algebra before, that we say the left-hand side equals the right-hand side. So it's saying two expressions are equal. So we state this with an equal sign. So the only difference between an algebraic expression versus an equation is you have this equal sign. So the equal sign makes it an equation. And the question I usually get asked at this point in teaching this is, do I need to memorize these definitions? Absolutely not. The whole point of introducing these definitions is to get you sort of introduced to to the terms, and so that you're not totally confused when we get to the actual math part of the course, and in other words, like solving the equation. So we're just introducing you. Okay, so what are like terms? So the terms having the same literal variable with with the same exponent. So they're called like terms. So for a term to be a like term, we need the variable, in this case, it's an x, so the letter, and the coefficient. The coefficient is the number in front of the variable. So the coefficient is the number in front, the x is the variable. So the variable has to be the exact same as the other variable, including the exponents, for it to be a like term. And I'll show you more examples of this as we go. But the coefficient in front does not need to be the same. The coefficient can be anything. It'll just tell us what the overall sort of answer is at the end. So for example, if I have 12x and negative 5x, the x in both of these is the same. So let me see if I can get my pen here. It's probably more helpful than, okay. So we have the x here and the x here being the same. And then, so these are like terms. So in this case, in example 2, we have 4x squared and 2x squared. The exponents didn't really come out super clear, but those 2's are exponents. So in this case, my x to the power of 2 and my x to the power of 2 are like terms because the letter and the exponent are exactly the same. So unlike terms are just the opposite. So they might have the same variable, but they have different exponents, or they just have different variables altogether. So those are unlike terms. So in example 1, we have an x and a y. So I can't combine those. They're different variables, different letters, so they cannot combine. So we have in example 2, x squared, y squared. Again, these have the same exponents, but the letters are different. So what if I had a 2x and a 2x squared? So these are not like terms because my x has a power. So I always say mathematicians are lazy and we don't write ones if we don't have to, but there's actually an exponent of 1 up there that we don't write. So you could see in the example 1, there was a 5x1, y, 5y1. So this x has an exponent of 1 and this x has an exponent of 2. So they are not like terms. So they need to have the same variable and the same exponent, but the coefficient can be different. And we will look at more of these. Okay, so I talked a bit about the numerical coefficient, and again, this is more definition stuff. You'll see a question like this on your assignment, just getting you used to some of the definitions so that when we get to actually combining the terms, it makes sense. So the number, the big number in front, we call our coefficient, or sometimes our numerical coefficient because it's the number. The x is our variable, but often we also call this the literal coefficient, in other words, the letter. But we often refer to it as variable. And then the number up above is our exponent. So let's answer this question. So the numerical coefficient has pretty much been given away. It's a 5. The literal coefficient in this case is an x, so it's the letter. The base, oh sorry, I apologize. So the literal coefficient is also going to include the exponent. So it's the x to the power of 4. The base is just the x. So it's the letter that is the base, but the literal coefficient includes the exponent. And then the exponent was the power of 4. So you will see a question like this on the assignment, which is why I wanted to take this up. All right, so we're going to sort of look at an example here, and we're going to actually combine some like terms, and we're going to talk about how we do that. We're going to start with some simple examples to get us sort of introduced and familiar with this, and then we'll move into some more advanced stuff. So simplifying, all it means is we need to combine our like terms, and in some cases complete operations. That's a little misleading at this level, but we just need to combine our like terms. So again, we're looking for that same variable and the same exponent on the variable, or in the last slide, our same literal coefficient. So we're just looking for the same letter, same exponent to be able to combine them. Now, the reason I like to introduce it this way is because, again, mathematicians are lazy, and if we don't have to write a number, we do not, and that number is typically a 1. So in the first example, we have an A plus an A plus an A. So what are the coefficients in front of these? So I'm going to write it out like this. We have a 1A plus 1A plus 1A. So again, mathematicians are lazy. All we're going to do is add, because we have the same variable, we can just add the coefficients in front. So 1 plus 1 plus 1 gives me 3 A's. And you can just look at that, right? We have A plus A plus A. So we have 3 A's. So in the next example with the B plus B plus B plus B plus B, again, we don't write it, but we have a coefficient of 1 in front of each of these. So we have 1, 2, 3, 4, 5 B would be combining my like terms. C, we have 1, 2, 3, 4, 5, 6 C's. So these are very simple examples, but just to show you that we just add the coefficients. So if I want to expand 5D, we're going to do the opposite. 1, 2, 3, 4, 5. E, we're going to go 1, 2, 3, 4, 5, 6, 7 E's. Oops. So often this is the question I get asked, is it wrong if I write a 1 in front? Absolutely not. You can write, so you could have wrote this 1D plus 1d plus 1d plus 1d plus 1d. 1, 2, 3, 4, 5. So you could have wrote it, so sometimes I will write the 1 properly and sometimes I won't, but you could have wrote it with the 1 in front. That's not wrong. As you go through this, the more sort of comfortable you get with it, you'll notice you stop writing ones too, just to save yourself time. So expand 11f, so I'm not going to do this one, but you're going to write f 11 times, right? So I think we get the point here. So that's our simple sort of simplifying and combining like terms. So now let's look at questions that don't just have a 1 in front, right? Let's look at something that has, so we have a 5c plus a 2c. So we're going to look at the coefficient in front. Well, first, actually, we're going to look and say, do I have the same variable? I have a c and a c, so those are supposed to be arrows. And they both have an exponent of 1, but again, mathematicians are lazy, we don't write the 1. So all we have to do is add the coefficients in front. So in your calculator, if this is something that you're not able to do in your head, that's totally fine. But for these examples, we have 5 plus 2, so we have 7c. So I'm taking the 5 and the 2, and I'm doing the operation it's telling me to do. So I did 5 plus 2, gave me that 7, and that gave me the 7c. Now, for this one, I'm going to write it out a bit bigger. We have 4 minus r. So the biggest thing to remember, a lot of students treat this r as a 0 because there's nothing in front. But remember, when there's nothing in front, there's actually a 1. And the operations it's telling us to do is for our takeaway 1r. So I'm going to take my coefficient of 4 and subtract 1. So 4 take away 1 is 3r. So we're just doing the operations. The letter comes after. So I always say, look at this as though you're just doing numbers. So 4 take away 1, you could probably do that in your head. If not, you can use a calculator. And then just throw the letter at the very end. So 5t minus 3t, so they both have a t attached to it with an exponent of 1. So we're going to go 5 minus 3, which gives me that 2t. And that's my answer. So you don't even have to write out this. I'm just kind of showing it so you can know where I came from. But yeah, we're just taking the coefficients, subtracting it, and then throwing the letter at the end. Okay, so now we're going to look at some examples that have maybe more than one variable. And okay, so in the first example, again, we're going to get into some questions where we don't always have the exact same variable in front. So I have a 10a plus a 14a. So what I tell my students is sometimes you can throw a line underneath or a double line underneath to sort of, when you have questions that have more variables in it. So for the first one, I have 10a plus 5b plus 14a. So I'm looking for the terms. So each of these are called a term. The term that has the exact same variable or letter and exponent. So this a and this a can be combined, and this b and this b can be combined. So I put one underline under my a's and then another one under my b's. Okay, so now some students like to write them out together. You don't have to do this step, but we'll do it just because we're just learning. So we're going to write the 10a and the 14a beside each other, and then the 5b and the 2b beside each other, just so that our brain knows sort of what to do. Again, you don't need to do this step. You actually can skip as many steps as you want, but I always tell students the more work you show, the more marks you can get. So if I can't see any of the thought process, and I don't care if it's messy, and most of us math teachers don't care if it's messy, the more work you can show, the better. So on the assignment that I've assigned you, and if you're not in this class, this might not make sense to you. If you're just watching this video as a resource, that's great. But for the students that are in this class, the assignment that I'm giving you, write as much work as you possibly can in the assignment so that I can give you part marks. So if you want to write this step, great. If not, that's fine too. So we have the 10a plus 14a, so that's going to give me a 24a. So I'm taking just the 10, adding the 14, that gives me 24a, and then I'm going to add the 5 and the 2, so I get 7b. So my simplified expression, so once it'll say simplify this or something, usually it says simplify the expression. So I get 24a plus 7b. That's as simplified as I can get. Can I combine these a's and b's? No, they're not the same variable, so I cannot combine them. That's as simplified as I can get. So this would be your final answer. Okay, so the next one, we have a 16t squared. So that's a t squared. Okay, so the next one, we have a 16t squared. So that's a t squared, the r squared, no, there's my other t squared. And then here's my r squared, and here's my r squared. Now, in this one, we're getting into these signed numbers, right? So the biggest thing you have to remember, in the first example, we had all addition, so it was easy peasy. In this one, you have to remember to also take the sign with the coefficient. So what do I mean by that? Let's just write this out with our t squareds beside each other. So 16t squared minus 4t squared. And then I have my negative r squared plus 2r squared. So if you notice here, I have a negative 4. So we have to be really careful not to do 16 plus 4 and get 20. You want to subtract 4. So if you need to use your calculator for this, that's great. I'm going to actually use the calculator for the second part, just because I think it'll be helpful to some of you. But anyways, 16 take away 4, I'm going to get a 12t squared. Sorry, that should be a 12. T squared. So 16 take away 4 is 12. Now for this negative r squared plus 2, sometimes students get a little confused when my negative number comes before my positive number. So if this is confusing to you, that's fine. So remember, there's a negative 1 in front of this r squared. Mathematicians are lazy. We don't write it, but that's a negative 1 plus 2. So let's quickly flip. Oh, I don't know how quick this will go. To my scientific calculator. Hopefully I can go as quickly as possible. So it was negative 1 plus 2. Okay, so again, if I want to put a negative in front, I don't use the subtraction key because that'll give you an error, but I'm going to go negative 1 plus 2 in my calculator, and that's going to give me a 1. So if you can't see that in your head, that's totally fine. You know, this calculator again is meant to be a tool, so you could think of it as just 2 take away 1, which is a 1, but sometimes sign numbers for students gets a little confusing. So that gave me a 1. But like, what if I had a negative 2 take away a 3? Oops. So if I had a negative 2 subtract a negative 3, say, we're just going to make sure we use that negative button, okay? So just, anyways, we got a 1. That was just a sort of sidebar there. Okay, so we got a plus 1r squared. So again, if you write that 1 there, that's fine, but we could have just put 12t squared plus r squared if we wanted. But there's nothing wrong with this answer, the 1 in front. Especially if you're new to this, it doesn't really make sense to not put things, you know, it can be a little bit confusing. Oopsies. Okay. I'm going to try to fit everything underneath, but if I have to erase some, I will. How do I erase though? Okay, actually, you know what? I am going to erase above. So because you're able to pause this, I know you can back up and look at it if you need to, but I'm just going to create some space here so that it doesn't get confusing. Okay. So let's go back to this. Okay, so now I have a 9x squared y. Then I have an xy squared. Then I have an x squared y, and then I have an xy. So the question is, which ones can I combine and which ones I can't? So we're looking, again, exact same letter, exact same exponent. So in this one, I have an x squared y. The second one, my y is squared, so it's not exactly the same. So I'm looking for one that has an x to the power of 2 and a y. There we go. That one I can combine with. Then I have an x with a y to the power of 2. And the last one I have is an xy. So actually, these two can't combine together at all. So I'm just going to put a little square around it just to make it different. And again, you don't have to do any of this. It's just, you know, some students it helps. So the ones with the single lines I can combine. So I get a 9 plus 4. So at this level, I'm not going to write out everything side by side. So I'm just going to go 9 plus 4. So I get 13x squared y. Okay, so that's my first underline. Then I have a negative xy squared. It can't combine with anything else, so we're just going to leave it as is. We don't change anything, we just leave it. And then I also have a negative 2xy that couldn't combine with anything else, so it just stays there. It doesn't change, and that's my final answer. So we only combine the terms that we're able to combine. The rest of them sit there. They don't get combined. They just stay the same. And in some of these questions, you might not be able to do anything. So some of the assignment questions might be there's no solution. Okay, so these are more simple. Probably should have came before. Let's see what's on the next slide. Let's skip to these ones. I think these ones are going to be more helpful anyways. So we have, okay. So we have, oops, why does it do that? Okay. So we have 6b squared. I'm going to look for another b squared. So those can go together. Then I have my h's to the power of 2, which are the same, so I can combine those two. So that's great. So if you can't do the 6 minus 14, you can do that in your calculator. But we're going to get a negative 8b squared. So those go together. And then my h squares can be combined as well. So we have a 7. Again, there's a 1 in front of this h. You don't have to write it, but just remember we have a 7 plus an h. So lots of students, sorry, h squared. We'll just leave it as 7h squared, but remember I have 7 plus 1, so I get plus 8h squared, or to the power of 2. Okay, so let's move on to b. So I have an f, then I have an r squared. There's my other f, and then I can combine these two together. So I have, okay, so this is a good one. We'll pop out the calculator again. This plus minus, we're going to do negative 2, subtract 10, gives me negative 12. I wonder if I could have done it negative 2 minus, no, you can't do it again. So yeah, you have to do negative 2, so the plus minus button, subtract 10. So it's not subtract a negative 10, it's just subtracting 10 is a negative 12. Okay, so we have negative 2 minus 10, so we got negative 12 in our calculator, f. Oh, we switched to blue, but oh well. Negative 12f, and then we have negative 4 again plus a 1, so negative 4 plus 1. So you can do that in your calculator, but you're going to get a negative 3r squared. Okay, so just use your calculator if you need to, that's totally fine. I am going to switch back to black though, because I just find it easier to read. Okay, now let's go into C. I have a G, oh, I have 3 G's, then I have an R, then I have just this number. So this is called a constant. You don't need to know that definition, but this 11 doesn't have anything attached to it, so it actually can't combine with anything. So we're just going to leave it like that. So I can combine everything with a single line. So I have 10 take away 4 plus 11, right? So we're going to go 10 take away 4, that gives me a 6, plus 11, that gives me 17G. And then we have plus 3R plus 11. So the G's combine, the R cannot combine with anything, so it just stays as is, and the 11 as well can't combine. Okay, question D. I have an X, no more X's, then I have an XY, and then I have, we'll just use, I don't like using the squares because then I have a hard time seeing the sign, but we'll put a square around it. No, I don't like that. How do I undo it? Just find it really hard to see when I do the square. Okay, do something else. Maybe just use a different color. My Y's, and then we'll use a different color for 13. We'll use purple. So 13. And again, you don't have to do any of this. It's just so that it's easier for you to see what I'm doing. Okay, let's combine the single line. So I have a 3 plus 4. So I get 7 X's. Then my XY, we're just going to leave as is. Then I have a negative 1. So again, we have a negative 1 plus 3. So negative 1 plus 3 is what you would type into your calculator, which is going to give you a plus 2y. And then my 13 can't be combined with anything else, so I'm going to leave it as a 13. I'd like to switch this up. I'd actually like to add to this. So so that's the answer. That's the final answer for that question. But what if I had plus 6, say? So what if I had a plus 6? So what if I had two constants? Then this number would change. So I could actually add, that's a 6. It looks like a B, but we're making it a 6. So I could add the 13 and the 6 together. So let's go back to black. So the 13 and the 6 could be combined, so they could be simplified, so we'd get plus 19, and that would be our answer if that was the case. So you can combine your constants, because they're just numbers, just like you would normally. If you did like 13 plus 6 without all of these other letters, you would just combine them together. So you can do that. So we're almost at the end of this of this lecture. So brackets. Brackets, you're going to see them all the time throughout this course. So there are reasons for this, but the easiest and the simplest way to memorize it or to think of it is that if a bracket is preceded or has a positive sign before it, so we discard the positive sign. So in other words, we drop the brackets and we just write it as is. So if there's a plus sign in front of the brackets, we drop it and write it as is. However, if there's a negative sign preceded, if the bracket is preceded by a negative sign, in other words, if the negative sign comes before the brackets, then we still drop the brackets and we drop the brackets and get rid of that negative sign, but everything inside of the brackets switches to the opposite sign. And then we just follow our normal rules for simplifying after that. So you're going to see this definition and be like, what the heck is she talking about? So let's show you what I mean. So in this example, we have a negative 2u subtract a negative 4u. So we have this in our sort of, we don't really use this sort of format very often, but you are going to see this in assignment and it is important to know. But what I like to do is have students rewrite this as we're familiar with, negative 2u minus negative 4u. Let's just write it out horizontally instead of vertically, and then it sometimes makes more sense in our brain. So there is a reason for this before we get into this, and we do talk about it when we get into the multiplication division, but whenever we have opposite signs, they become a negative, and whenever we have the same sign, they become a positive. So in other words, the negative sign does affect things. The positive sign doesn't always affect things. But in this case, whenever we have this example, we want to just think of it as the negative outside of the bracket. So our rule says, I'm just going to keep this as is, there's a negative in front of this bracket. So we're going to drop that negative and get rid of it. But whatever was inside the bracket switches. So we get a plus 4u. So if you look back at our rules over here, it makes sense that we would, right? Because we had two negatives beside each other, it becomes a positive. But instead of having you memorize those rules, we'd like to just say, if there's a negative in front of the bracket, drop it. And then after you've done that, you continue to simplify if you can. So sometimes you can't. In this case, we can. So we get negative 2 plus 4 gives me a positive 2u. Again, you can put that into your calculator if you need to. That gives me a positive 2u, and that is my final answer. So in the next question, we have some additional, we have a pretty lengthy expression here. So my 5x minus 3y, if there's nothing outside of it, because when the first term comes, again, mathematicians are lazy, they don't write a plus sign unless they have to. The plus sign can be dropped, in other words, but if there was a negative, it would have to be written there. And the reason they can do that is because it doesn't affect what's inside. So there's actually a plus sign in front of here. So all I'm going to do is drop the brackets and not change anything inside. So we're done. But we have to worry about the negative. So let's actually go ahead and circle them so that I remember that these are going to change things. These are going to be very important in what happens. So this negative in front of the bracket, again, I'm going to get rid of it, but everything that was inside the bracket changes. So This 2x has no negative in front of it, which means it was a positive. So again, mathematicians are lazy. We don't write a plus sign unless we have to. So this is actually a positive 2x inside the bracket. So we're going to switch it to a negative 2x. This negative 4y will become a positive 4y. And that is that bracket. So we've finished and simplified that. Now, this next bracket just has a plus sign in front, so we don't have to switch anything. We drop the brackets and write it out as is. So our negative x plus y, so exactly like it was in the brackets. In the next one, we have a negative outside of the bracket. So this negative x becomes a plus x, and the plus 2y becomes a negative 2y. So we flip those. Then we proceed with combining our like terms. So I have my x, 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 x. So I have 4 x terms that I can do, and let's just do a different color here. Then I have my y, 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 y. If it's easier for you, you can write all of your x's out together and combine them that way. But you can also just use your calculator. So you're going to go 5, take away 2, sorry, where are we? Take away 2, take away 1, plus 1. So we're going to end up with 3x. And if you couldn't do that, again, just type it into your calculator. So 5 take away 2 gives me a 3, minus x will give me a 2, and then we'll add back that x, which gives me a 3x. And then for y's, I have negative 3 plus 4, so that gives me a 1, a 2, and a 0. So actually my y's cancel out. Let's double check that. So negative 2 plus 4, so that's going to be a 1, a 2, and then take away 2. So I actually get 0y. You can write a 0y, that's fine, but whenever we have a 0, we just get rid of it. So the answer to this is just going to be 3x, and that's our simplified expression. Okay, move to the next slide. Okay, this is our last example. Again, if there's more examples that you need, you can refer to the addition subtraction booklet that you'll want to look at. It has lots more examples and also some practice exercises that you can do on your own from the booklet, and then the answer keys are at the back, so just extra practice. Okay, so let's do this one. There's nothing different. Sometimes we have 3 terms in a bracket. That's okay. The same rules apply. So again, there's no sign outside of here, so actually there's a plus sign. So what we're going to do is drop the bracket and write it as is. So we have 2x squared plus 3y take away z. Now, there's a plus side outside of this one, so I'm not so worried, but I am worried about this one. Not worried, but you know, we just know that something needs to be done there. So for this one, we're going to write it as is. So we get a plus 4x squared minus 2z. Then we're going to drop that bracket. We get a plus 6x squared because it was a negative. Then we're going to drop that bracket. We get a plus 6x squared because it was a negative, plus 4y because it was a negative, and minus 10z. Sorry, I kind of ran out of room there. Hopefully you can see that. So plus 6x squared plus 4y because it was a negative, and then take away 10z. So I can combine my x squareds. I got 3 of those. And then I can combine my y's. I got 2 of those. And then I can combine my z's. I got 3 of those. Okay. So I have x's 2 plus 4. So I got 12x squared. And then my y's, I have a plus 3, 4. So I got plus 7y. And then my z's, I got negative 1, so negative 3, negative 13z. So what we do is we drop the brackets, and then we can combine our like terms. And then I can't go any further with this because I can't combine my x squareds with my y or my z. So this would be my final answer. Okay, so that's it for this lecture. This covers the addition subtraction booklet or unit. Okay, great. Thanks for watching.